You know that chalky tablet you might take for heartburn? Ever really think about what it is? Well, today, we're going to peel back the label on one of the most common compounds you'll find in pretty much any medicine cabinet. And it turns out, it's got a fascinating story. It's a simple mineral with two totally different jobs inside your body. Okay, so let's kick things off with a bit of a puzzle. What could possibly connect something like a seashell, a giant limestone cliff, and that acid tablet sitting in your drawer? I mean, they seem completely unrelated, right? But believe it or not, they share a secret identity. And the answer is calcium carbonate. You might see it written as CaCO₃. And this stuff, it's an incredible compound. It's a natural building block found pretty much all over our planet. But as we're about to find out, it also plays a huge role inside our own bodies. All right, so let's really get into this. To get a handle on calcium carbonate, I want you to think of it as having two completely different jobs. On one hand, it's like a quick response firefighter. It rushes in to put out that fire of heartburn, It acts in minutes. But on the other hand, it's a long-term construction worker, patiently and steadily building up the framework of our bones over a lifetime. It's wild, right? Two totally different missions, all from the same compound. So let's start with that first job, the emergency responder. This is calcium carbonate in its antacid mode, the one that gives you that super fast relief when you're dealing with indigestion or heartburn. So what exactly is an antacid doing down there? Well, it all comes down to some pretty simple chemistry. See, your stomach makes this really powerful hydrochloric acid. An antacid is just a base, and its whole job is to go in and directly neutralize that acid. It brings the stomach's pH level back up, and poof, that burning feeling starts to fade. The whole process is actually a super straightforward three-step reaction. Step 1, the calcium carbonate hits your stomach. Step 2, it immediately finds and reacts with that hydrochloric acid. And step 3, the result. The acid gets neutralized, and what you're left with is water, a salt called calcium chloride, and carbon dioxide gas. Now hang on, that last part, the carbon dioxide gas, that's the crucial point. This isn't just some boring detail from a chemistry class. That CO2 gas, that is exactly why taking an antacid can sometimes make you feel a little bloated or, gassy. It's a direct side effect of that chemical reaction doing its job. Okay, so that's the firefighter. Now let's switch gears and talk about its second mission, the construction worker. And this job is a much, much slower and more complicated journey. Here, calcium carbonate is taken as a supplement to give your body the raw material it needs to build and maintain strong bones. But here's where it gets really interesting and, frankly, a little inefficient. Just because you swallow a calcium pill doesn't mean your body actually uses all of it. Not even close. In fact, if you look at this, a healthy person only absorbs about 15 to 30% of the calcium they take in. The rest, the vast majority just passes right on through. So, what gives? Why is that? Well, it's because your body has these really strict gatekeepers, these bouncers at the door for calcium. For calcium to even get a chance to be absorbed, you need a few things to go right. First, you need enough stomach acid just to break it down and dissolve it. Second, you gotta have enough vitamin D. Think of vitamin D as the shuttle bus that carries the calcium into your bloodstream. And finally, your body just can't handle a huge flood of it all at once. It absorbs small, manageable doses, like under 500 or 600 milligrams, way, way better. Okay, so knowing all this science is great, but how do we actually use this information? Let's get practical. This next part is basically the user's manual for getting it right when you're taking calcium carbonate supplements. All right, picture this. You walk into a pharmacy, you pick up a bottle of calcium, and right there on the front, in big numbers, it says 1,250 milligrams. And you think, wow, that's a huge dose, that's gotta be good. But, and this is the really critical question, how much of that 1,250 milligrams is the pure, usable calcium that your body actually needs? This is a super common point of confusion, and it trips a lot of people up. The answer? Only 40%. Yeah, that's it. See, the calcium carbonate molecule itself is made up of calcium, carbon, and oxygen. The part your body is actually after, the elemental calcium, only makes up 40% of that total weight. So, let's do the math. That big 125 milligram tablet is actually only giving you 500 milligrams of the good stuff, the elemental calcium your bones can use. And this is the key takeaway, for sure. You've got to look for that number on the supplement facts panel on the back, not the big, flashy number on the front of the bottle. Okay, so to put this all together, how do you maximize your dose? Here are the best practices. First, always take it with a meal. That way you're using the stomach acid that's already there to help dissolve it. Second, divide your doses. Don't take a huge amount at once. Your body absorbs smaller amounts way better. Third, make sure you're getting enough vitamin D. Remember the shuttle bus. And finally, a simple one. Drink a full glass of water with it to help everything dissolve. Now, of course, like pretty much anything you take, calcium carbonate isn't totally without risks. It's generally very safe, but it's really important to know about the potential side effects and especially the interactions with other meds. So you can see we have two categories here. First, there are the common and usually pretty mild side effects. We already talked about the gas and belching from that chemical reaction. Constipation is also a super frequent complaint. But then there's the serious stuff that can happen with overuse over a long time. You could develop something called hypercalcemia. That's just a fancy term for dangerously high calcium levels in your blood. Or even a condition called milk alkali syndrome, which is a really serious issue that can damage your kidneys. Another major red flag you have to watch out for is drug interactions. Calcium can basically act like a roadblock in your gut. It can bind to other medications and stop your body from absorbing them properly. This is a really big deal for things like thyroid medicine, some antibiotics, and even iron supplements. So the rule of thumb is to create a safety window. You want to take your other meds at least 2 hours before your calcium or wait 4 to 6 hours after. Okay, we have covered a ton of ground here, right? From stomach acid chemistry all the way to how our bones are built. So let's boil it all down to the key takeaways you really need to remember. You know, this quote from the source material really just says it all perfectly. Success with calcium carbonate really hinges on understanding its two different roles. You have to get its limitations, like that low absorption rate we talked about, and you have to be smart about how and when you take it to avoid problems. It's all about being educated. So I'll leave you with this final thought to chew on. Knowing what you know now, that this one simple compound is both a super fast firefighter and a slow and steady construction worker, how does that change how you think about those supplements on your shelf? It's just a great reminder, isn't it, that even the most common everyday things can have a really surprising story.